the ceiling. And here's the book. We're going to push it like that, let's say, so the force is going to be up this way. According to 14, it is 85 newtons. So the pushing force is 85 newtons. And the angle it makes with horizontal is 55 degrees. So the first thing is, if you have a force that is not on the x or the y axis, you should find its components. So I'm going to get the x and the y here for this force. So the x is 48.8, and the y is 69.6. All right, so now that we have that drawn, we can do our free body diagram. So you got the weight of the book down, it's going to be Fg. So that's the weight of, or the mass times 9.80 is 39.2 newtons. And then you have your x component, pushing force, Fpx, 48.8 newtons. And then the y force, Fp in the y direction, is 69.6 newtons. And you know you're going to have some kinetic friction to your left. We don't know what that is. Ultimately, we're looking for the coefficient. So we're going to need to get that in order to get the coefficient. The other thing is the normal force. The normal force is going to come down out of the ceiling because the ceiling is the surface in this case. So if you have 69.6 newtons up, you got to have 69.6 down, right? Because it's in equilibrium. So you do 69.6 minus 39.2 and get 30.4 as your normal force. So now let's find this friction force, if we can, and then we can get the coefficient. So we're told the mass of the block is 4, and its acceleration is 6. So sum of the forces in the x direction equals ma. So you're going to have Fp in the x plus kinetic friction equal to ma. So that's 48.8 plus friction equals 4 times 6. So the kinetic friction, after you solve for it, you get negative 24.8. So this is 24.8 now. And now you can solve for your coefficient. So you do mu k is 24.8 over your normal force, 30.4.